Next, we're going over section 14.3, and we're going to talk about cause and effect. So, cause and effect. A different type of data collection process is needed when we are trying to establish connections between a cause and an effect. Does taking a math class increase your chances of getting a good paying job? Does repeating exposure to secondhand smoke significantly increase your risk for developing lung cancer? Does a daily dose of aspirin reduce your chances of a heart attack? These are all questions that we would like to know the answer to so that we can modify our behavior and give ourselves a better chance of living a quality life. But sometimes it's very difficult to know the answer. Sometimes we think the answer is obvious and it's quote unquote common sense, but our common sense turns out to be wrong. And so statistics is what we can use to get a good idea, support our behavior, support our conclusions. And sometimes when the statistics is wrong, then this is people will use this as a as a reason to not believe statistics. But statistics is just like any other tool. It can be used for good. It can be used for bad, and sometimes those things are happen accidentally. Sometimes they happen on purpose. Sometimes it's on purpose that people are using it for bad, but sometimes it's just an accident. But you, as a consumer of information, should have a basic understanding of some of the ideas behind these things. Do the benefits of hormone replacement therapy for women over 50 outweigh the risks? Another question we might want to know the answer to. Okay, so cause and effect. When we want to know if a certain cause X produces a certain effect Y, we set up an observational study in which cause X is produced and its effects are measured or observed. If the effect Y is observed, then it is possible that X was indeed the cause of Y. We have established an association or correlation between the cause X and the effect Y. Right? So there's lots of very intelligent people who use this reasoning incorrectly, right? So just because you can associate a correlation between two things doesn't mean that one causes the other, right? And so very common for people to make faulty arguments with that. And you understanding this will help you make better, more informed decisions. The problem, however, is the nagging possibility that some other cause Z different from X produced effect Y and that X had nothing to do with it. Just because we established a correlation, we have not established a cause and effect relation between the variables. Statisticians like to explain this by a simple saying: correlation is not causation. Just because you found a correlation between two variables doesn't mean that one causes the other. And people will use this all the time. Common place to use this is education, where people will say, well, this school over here gets funded at this level, and so that is why it produces better students. And by better, we mean higher test scores, higher rates of going to college. And that seems like a very solid, reasonable argument. But if you look at the data and you find that there isn't really, although there is a correlation, there's not a causation. Simply increasing funding to the schools does not automatically produce better results. There are lots of underlying variables at play. In a school situation, you may have the better funded schools because the tax base is higher, and the tax base is higher because a lot of the people are professionals, and professionals are already educated, so they're going to instill that desire to be educated into their kids, and so those kids go to school and are going to be more inclined to take school seriously, and so it's not just the act of spending the money. There's all these other lining characteristics. Now, that's not to advocate that there shouldn't be a base level of spending. Your school shouldn't be running down, but it just simply spending more money isn't going to get you the results that you want, although it seems like a reasonable argument that it would. So how are we going to figure this out if you have a causation? So how can we try to establish a cause and effect relationship? One way is a type of study called a clinical study or clinical trial. Generally, clinical studies are concerned with determining whether a single variable or treatment, usually a vaccine, a drug, therapy, etc., can cause a certain effect, a disease, a symptom, a cure, etc. The first and most important issue in any clinical study is to isolate the cause, treatment, drug, vaccine, therapy, etc., that is under investigation from all other possible contributing causes. So some vocabulary. So a confounding variable is any other variable that could produce the same effect, right? So it doesn't have to be that just the act of spending more money at the school is what's causing the better outcomes. It could also be all the parents in that district being educated and then putting on that value onto their students. And so then we're going to do studies, and we would like a controlled study. And the subjects are divided into two different groups, the treatment group and the control group. The treatment group consists of those subjects receiving the actual treatment, and the control group consists of a subject that are not receiving any treatment, and they are there for comparison purposes only. Randomized controlled study. The subjects are randomly assigned to either the treatment group or the control group. And again, this is all how you're going to make your study, and the data that you collect is only as good as how you set up your study. If your groups aren't chosen at random, if you have all men in one group and all women in the other, or all of one type in one group and all of another type in the other, how valid is your data? So that's why a randomized control study is a good idea. Now, there is still one major difference between the two groups that can significantly affect the validity of the study: a critical confounding variable known as the placebo effect. This is kind of strange. Most people have heard about this, but just the mere fact of thinking that you're getting something that's going to make you better tricks the mind into actually getting better or feeling better anyway. And so this is called the placebo effect. The placebo effect follows from the generally accepted principle that just the idea that one is getting a treatment can produce positive results. This might seem counterintuitive. It might seem like it's not very not feasible, but it is generally accepted that this is possible. Thus, when subjects in a study are getting a pill or a vaccine or some other kind of treatment, how can the researchers separate positive results that are consequences of the treatment itself from those that might be caused by the placebo effect? When possible, the standard way to handle this problem is to give the control group a placebo, right? So if you're going to test a pill to see how it works, then you have a control group that is given a placebo, and a other group that is given the actual medication, and then you can compare the two results. If your two results aren't that much different, then you can't really say that your pill is working. Placebo, a make-believe form of a treatment, a harmless pill, an injection of saline solution, or any other fake type of treatment intended to look like the real treatment. A controlled placebo study is a controlled study in which the subjects in the control group are given a placebo. And by giving all subjects a seemingly equal treatment, the treatment group gets the real treatment and the control group gets a placebo that looks like the real treatment. We do not eliminate the placebo effect, but rather control it. Whatever its effect might be, it affects all the subjects equally. It goes without saying that the use of a placebo is pointless if the subject knows that he or she is getting a placebo. So that brings us to the next term, blind study, a study in which the subjects don't know if they are getting the treatment or the placebo. A double-blind study is a study in which neither the subjects nor the experimenters know who is getting the real treatment and who is getting the placebo. So we have some exercises here to help us get familiar with these vocabulary. You might want to pause the video and try this on your own. Okay, exercises through 33 through 36 refer to the following story. The manufacturer of a new vitamin, vitamin X, decides to sponsor a study to determine the vitamin's effectiveness in curing the common cold. 500 college students having a cold were recruited from colleges in the San Diego area and were paid to participate as subjects in this study. The subjects were each given 2 tablets of vitamin X a day. Based on the information provided by the subjects themselves, 457 of the 500 subjects were cured for their colds within 3 days. The average number of days a cold lasts is 4.87 days. So it looks like this cut this down. As a result of this study, the manufacturer launched an advertising campaign based on the claim that vitamin X is more than 90% effective in curing the common cold. Okay. Describe as specifically as you can the target population for this study. So it seems to me that the target population for this study is Americans suffering from a cold. So we're making this vitamin to help people. This is supposed to help them fight a cold. So I think it's Americans suffering from a cold. You might argue that it's just Americans in general because you don't take vitamins just to ward off a cold. You take it to stay healthy. So either way. 33B. Describe the sampling frame of the study, for the study. So if you remember from the previous sections, the sampling frame is where we got our samples from. And we got all our samples from 500 college students having a cold, 500 having a cold recruited from colleges in the San Diego area. So our sampling frame would be college students in the San Diego area suffering from a cold. Okay, 33C. Describe the sample used for the study. Right, so the 500 college students who suffered from the cold, right? 500 college students. From the San Diego area. And there we go. Was the study a controlled study? So again, a controlled study. The subjects are divided into 2 different groups, the treatment group and the control group. So that's not what's going on here. We didn't have 2 groups. And so was the study a controlled study? 34A, no, only one group. We only observed one group. Okay. 34B. Okay. List 4 possible causes other than the effectiveness of vitamin X itself that could have confounded the results of the study, right? So again, since you don't have a control group, um, one of the possibilities is always the placebo effect. Placebo effect. Number 2, right? So the number of days a cold lasts is 4.87, but we're going to agree that that is for the general population. You're testing young college students who might be healthier than the general population, and so they may be able to fight off that cold better and cut it down to the 3 days without the vitamin. So so testing young college students. Number 3, so list 4 possible causes other than the effectiveness of vitamin X itself that could have confounded the results. Okay, so we're in San Diego, maybe the weather. And it turns out that another reason why um, you could be getting bad results is people uh, miss um, misdiagnosing, right? And so part of that may be that you self-reporting is the word I was looking for. Um, when you pay people, then some people feel obligated to give you a positive result. I'm sorry, a positive review. So having paid these individuals might skew their opinion and give them better reviews than they were supposed to. So paid self-reporting. Okay. 35. List 4 different problems with the study. List 4 different problems with the study that indicate poor design. Right. So there was no control group. Right. There was no accounting for the placebo. Right. So 35. No control group. No accounting for placebo. Um, your sample was not random or representative of the population. And a sample not representative of population. And so you, as a consumer of information, can't just take the information at face value. This is why you are going to school, so that you can learn to analyze and look over information. And so when you can't just, you have to dig a little deeper. Now, probably for some vitamin, you're not going to be that concerned with digging too deep, but with other things, you might want to look a little deeper. Make some suggestions for improving the study. Again, just go to number 35 and fix those. Get a control group. Do a double blind study. Do a blind study. Don't allow people to, don't pay people. Don't allow people to self diagnose or self report. Somebody should, monitor their temperature, find some way of determining whether they've gotten over the cold. A very important section, because you see statistics every day. You use them. It's the only tool we have to make very important decisions, life and death decisions, sometimes quality of life decisions, a lot of the times. And there's no magic ball to help us make those decisions. And although this is a not 100%, it's the best tool we have. And so then you need to learn how to use this tool. So very strongly encourage you to read the book, because it goes over a lot of this vocabulary in more detail, and practice and do your homework. So here's your homework for this section, 37 through 48 all. This will be due next week. And stay safe, and see you next time. Bye.